In this video, we're going to talk about or try to understand the meaning of dot product of vectors. So let's say we have vectors A and vector B, right? And we know that dot product of the two vectors A and B is given by A into B into cos theta. Right? This is a scalar quantity. These are merely numbers. This A stands for magnitude of A, B stands for magnitude of B, and cos is this cos theta is cos of angle between vectors A and B. What does this exactly mean? That's what we're going to understand in this video. So let us draw two vectors A and B, and I'm going to take them in no specific direction. Let us say this is vector A, right? And let us say this is vector B, and this is, let us say, vector B, right? Again, I'm taking at any random angle. This is vector B, and this angle is theta. So I have considered two vectors A and B, and their lengths are different, and they are at an angle theta with each other. What does the dot product of these two vectors mean? If I go back to this equation, right, let me write it over here. A dot B is equal to A B cos theta, right? I can write this equation as B into A cos theta, right? B into A cos theta. These are numbers, right? And AB cos theta would also be equal to B A cos theta, right? So I can write it as B into A in cos theta. What does A cos theta mean, right? To understand A cos theta, what I'll do is I'll take a perpendicular, drop a perpendicular from A onto vector B, and let us see what happens. So I'm taking a perpendicular from this end point of vector A onto vector B. So I'm just drawing a line. Okay. And let me give these names. This is point P, this is say point Q, and this is say point R. Now, this is theta, right? So cos theta will be equal to adjacent side, that is PR upon hypotenuse PQ, right? Therefore, cos theta will be equal to PR upon PQ. PQ is the magnitude of vector A, so I can write it as A, where A stands for magnitude of vector A, and therefore PR is equal to A cos theta, right? PR is equal to A cos theta, right? So this particular length PR is A cos theta, right? And if I go back to this particular formula, I can see that I got A cos theta here. So what is the meaning of A cos theta? If you look at this diagram again, what it means is A cos theta, that is this particular distance. I'm showing it next to it. Actually, it's on the same line, but just for understanding purpose, I'm showing next to it. This particular length is A cos theta. And what it means is it is the projection of vector A on vector B. It is a projection of vector A on vector B. A cos theta is that part of A which is having the same direction as vector B. A cos theta is that part of A which has the same direction of vector B. So essentially I am multiplying this particular projection of A and vector B. If I go back over here, I am multiplying B and A cos theta, where A cos theta is projection of A on B and the magnitude of B. And since both of them are in the same direction, the direction loses its significance, because if this is A cos theta and this is B, both of them are in the same direction, and it's basically a product of two scalar quantities, or two quantities which do not have direction, because they are both in the same direction. So once again, A cos theta is the projection of A on vector B, right? In fact, if we repeat this exercise, we can also do it in this particular form, right? I can do it in this particular form. A dot B is equal to AB cos theta, and I can write it now like A into B cos theta, right? And I'll repeat this particular exercise. So let me draw again the same vectors, approximately same, right? We are not too worried about the magnitude. So let us say this is vector A, this is vector A, and I'll draw vector B at nearly the same angle, right? So this is vector B, and I'll try to take approximately the same length. Yes, it's nearly the same. So this is vector B and this is theta. Now, what is B cos theta? I'll use the same logic. From B, I'll drop a perpendicular onto vector A. For that, I'll have to extend this particular vector. So I'll extend it. And from B, I'll drop a perpendicular onto vector A. So how do I get it? Yeah, this is it. This is it. So I got 2 pointer points. Let me give them again name P, Q, and let me call this point R. Okay. So again we are into the same situation. So now what is B cos theta? Right. So if this is theta, then cos theta is equal to adjacent side. In this case, this is perpendicular. So this is the hypotenuse. So this becomes the adjacent sides. Let me change the names so that I have similarity with the previous case. Let me call this Q, right? Okay. So this is PR and upon hypotenuse, which is PQ, and this is PR upon PQ is, as you can see, vector magnitude of vector P, and therefore PR is equal to P cos theta. So we can come back to the same thing. What is PR? PR is the projection of vector B on vector A, right? So this particular link, let me draw it next to it. So let me draw it next to it. This particular length, this much. This is B cos theta, right? So when I do dot product, I am multiplying P cos theta, which is the projection of P onto A and vector A, right? And if you actually do it, if you measure these angles and you measure the magnitudes, you will find that this particular length into A, that is B cos theta into A, will turn out to be equal to A cos theta into B, right? That's what we, if you had actually measured these angles and if you had actually taken magnitudes of A and B, we could have got that. Fine. I hope this has given you some idea as to what vector product is. So dot product is. I'll summarize this. When I write A dot B, right? What A dot B means, it is the product of the magnitude of A. So that is of magnitude of vector A. And it is the product of magnitude of vector A and that part, or that magnitude part of vector B, which is in the same direction as vector A, right? And this is vector A into P cos theta. Cos theta, and it is also equal to, it is the product of the magnitude of vector B and that part or that component of vector A, which is in the same direction as vector B, which is equal to B into A cos theta. Thus, A dot B is equal to A into B cos theta, that is same as B into A cos theta, and therefore it does not have any integration. I hope this video has helped you understand what a scalar product is all about, and in the next video we will try to similarly look at what vector product or cross product is all about. Thank you.